We're going to continue our discussion about lines and equations and extend it to parallel and perpendicular lines. We're going to look at it in two different lights. We're going to look at how do I determine if something or if two equations represent parallel or perpendicular lines. And then we're also going to look at how do I write an equation of a line either parallel or perpendicular to a line that I'm given. So the first part is determining if something is parallel or perpendicular. So first of all, I just want to make sure, do we remember what a reciprocal is? So we looked at reciprocals a lot when we looked at multiplying fractions, when we looked at dividing fractions, and we looked at leaving the first fraction alone, changing multiply, divide, and then flip the second fraction. When we flip the second fraction, what we're doing is we're using its reciprocal. Oftentimes, dividing by fractions or dividing with fractions is defined as multiplying by a reciprocal. And then, of course, remember, opposite means change a sign. So, for example, the opposite of 5 would be -5. When you're looking at parallel lines, the symbol for parallel lines often looks something like this, and they are just two lines that never touch or never intersect. Perpendicular lines, on the other hand, have this as their symbol, and they are two lines that intersect at a 90-degree angle. So we need to know, how do I know if A, two lines are parallel, and B, two lines are perpendicular? Well, notice that two parallel lines, they never intersect because they're going rise over run at the exact same pace. So in other words, two lines are parallel because they have the exact same slope. Perpendicular lines, it's harder to see, so I'm just going to go ahead and tell you. Two lines are perpendicular if their slopes are their slopes are opposite reciprocals. So for example, 2/3 and -3/2 would be opposite reciprocals. Another example would be -4 and +1/4. Those would also be opposite reciprocals. So I flip it and I change the sign. If it was positive, I make it negative. If it's negative, I make it positive. So we're going to look at a couple examples. I have three in determining if two given graphs or two given equations are parallel, perpendicular, or neither. And we're going to make that decision by looking at their slopes. So even though it's talking about their graphs, we're not actually going to graph them. So I'm going to go ahead and jump into example 1. Well, I know if I'm looking for slope, the best way to find slope from an equation is to first change it to y = mx plus b form. So I notice that in my first equation, so I'm going to call this equation 1 and this equation 2. In equation 1, I don't have to rearrange it. It's already in y = mx plus b form. So I'm going to go ahead and say it has a slope of -1/3. Equation 2, on the other hand, is not in y = mx plus b form. So I'm going to manipulate or rearrange this equation to put it in that form. And I'm going to start by subtracting 2x from both sides. After I subtract 2x from both sides, I'm going to be left with 6y = 12 minus 2x. Dividing both sides by 6 to get y alone, I realize that both of these terms are being divided by the 6. So 12/6 I can reduce down to 2 minus, and then 2/6x. So I know my slope, m, equals -2/6, and my first instinct is to say neither. However, I know that -2/6 is not in simplest form. Since they're both even, it can be reduced by 2, giving me an m of -1/3. So notice that my slopes are in fact the same, so I'm going to go ahead and classify these as parallel lines. Looking at example 2, I'm going to go ahead and go through the same process. In this example, neither equation is in y = mx plus b form, so I'm going to have to manipulate both equation 1 and 2. So in equation 1, I'll start by subtracting away the 4x, giving me -3y = 36 subtract 4x, and then I'll divide by a -3, giving me y equals 36 divided by -3 gives me -12. -4/-3 becomes plus 4/3x. I'm going to go ahead and say my slope, my m, is 4/3. Doing the same with equation 2, I'm going to start again by subtracting off of 3x, giving me 4y = 20 minus 3x. I'll divide by 4, giving me y equals 20 divided by 4 reduces to 5 minus 3 over 4x, and I have a slope of negative 3/4. Well, I notice that 4/3 and negative 3/4 are a flip or a reciprocal of one another, and they are also opposite. So I'm going to go ahead and conclude that these are perpendicular lines. And if we look at these in class, I would love to show you in class on a graphing calculator how these really do amount to parallel lines in the first example and perpendicular lines in the second. Now that you've seen me go through 2, example 3 would be a great example for you to pause and try on your own. And in example 3, again, I want to first change to y equals mx plus b form. So I'm going to take equation 1 and 2 and do that to both of them. In equation 1, I'll start by subtracting 3, giving me 3y equals 2x subtract 3, and then dividing by 3 to get y alone. 2 over 3 stays 2/3. Minus 3 over 3 becomes minus 1. Now that I'm in y equals mx plus b form, I can say I have a slope of 2 over 3. Manipulating the second equation to be in y equals mx plus b form, I'll start by adding 3x to both sides, and I get 2y equals 6 plus 3x. I'm going to go ahead and divide by 2. 6 divided by 2 leaves me with 3. 3 divided by 2 leaves me with 3 over 2. And picking out my slope, I see that I have a slope of 3 over 2. Comparing my two slopes, I see that they are reciprocals. However, they are not opposite of reciprocals or opposite reciprocals. They're both positive. So I'm going to go ahead and I'm going to conclude that these are neither parallel nor perpendicular. So again, changing to y equals mx plus b form allows us to pick out the slope, which we can then check. If the slopes are the same, we can go ahead and say they are parallel, and if they are opposite reciprocals, we can go ahead and say they're perpendicular. Again, make sure you bring your notes with you to class so you can use these as a tool when doing your practice.